Welcome back to my YouTube channel. I want to really appreciate everyone that have watched my video, especially the video I made for question 1 on mechanics, the one I did for question 3 on electricity, those that commented, especially those that commented politely, telling me one correction or the other, suggesting. I really appreciate every one of you. Thank you so much. Those that subscribe to this channel, those that liked the video, there's so much comment, there's so much love you have shown me. I really appreciate every one of you. Thank you so much. May God bless every one of you as we keep learning and growing together. Okay, today I'm doing another video for the question number 2, which is optics. Please like this video, share it, and subscribe to this channel. When it comes to optics, you really have to be very careful before answering the question. I had to do the question 1 and question 3, and I want to take my time to do question 2 because optics is not something you rush into. Before you answer any question in WAEC on optics, you have to follow the instruction very well. Please follow the instruction, read it line by line, and do what you are expected to do, because multiple questions can come out when it comes to optics. You cannot really predict and say this is it and this is it. No, for optics there are thousands of questions that can come out from it. That's why I made this, and I'm going to explain a lot of different questions that will come out. Then we'll pick one, we'll just pick one, get the solution, and then plot the graph. Look at this one, is another question. This one came out in 1989. This is another year. This one came out 2 times. It was repeated 2 times. I had to carry past question and do my research before doing this video. So watch this video to the end so that you will get the points, what I observed from my research as I carried past question to check how questions are coming out on this particular one. So you cannot just rush into optics. You have to understand the theory as well, so that if you have good knowledge of Snell's law, how to determine the refractive index of a glass, you'll be able to, even if during the practicals you're having issues, you can easily get back to your feet with understanding of the theory. And also it takes time, because you have to neatly draw. You're drawing 5 things, and you are tracing like 5, doing for 5 angles. So before you answer question on optics, watch this video to the end. So let's go right into describing the various forms that the question can come out. Then we'll now use one and practice to the end so that we can get an end point, plot the graph, and see how it goes. Please don't forget to subscribe to this channel. I thank every one of you for always staying around, dropping your comments and suggestions, and watching other videos. Thank you so much. This video is a thorough guide on different ways, things you should expect. Remember, I told you that for optics, you can have different questions, but you have to practice and practice to the point that any question that comes up, you will follow the instruction line by line and get what you are looking for. So I'm going to just point all this. I'm going to point them, likely things. Then we are going to focus on the last one so that we'll do experiment, because most of them have the same format of putting the 2 pins, getting the emergent ray. So we'll do that one, which is the major one, conclude on one, then plot our graph so that you can see how to plot graph for this type of experiment. So do well to watch this video to the end. And also this video can be a guide to teachers to prepare their students in SS2, that's year 11, for exams. If you want to set your practical exams, I'm going to tell you the different years in the past questions that treated all this so that you can prepare your students very well. So let's look at the first one. This one is from WAEC 19 89. So once you put your glass block EFHG, make sure that the distance from here to here is 1/4 the distance from this point to this point. From here to here, 1/4. Then you now draw the normal. You draw the normal KL. Put pin 1, pin 2, and ensure that pin 1, pin 2, they are very far apart from each other. Let's say like 4 cm is okay. Just make sure they are apart from each other. Then you come back, remove the glass block, and view from HG to get this point, which is the imaginary, where this pin 1, 2, 3, 4 are in a straight line. This is the major format for almost all of them. Then the different thing that you will get for this particular one is that you will get a point called T1. Join T1 to another point X. This is the angle of refraction. This is the imaginary. So what are you expected to get? Get a point T1, you label it T1, and then you measure KL. You extend this line to meet KL at another point called SL. So you need this point and you need this point. With that, you're going to measure ST1. You measure from here to this point, ST1, and also measure from that X1 to T1. So you need two things for this particular one. From distance from here to here, ST1, and the distance from here to here, X1, T1, so that you are going to repeat it for 35, 45, 55, and 65. And at the end, you plot a graph of ST against XT. That's for this particular one. This second one is from 1992, WAEC 1992. This one came out in 1989. This one came out in 1992, where you are expected to find the lateral displacement D. Remember, the format is usually the same. You put the incident ray, get P1, P2, then view it from this side to get P3 and P4. That's the imaginary. This is the angle of refraction. Then for this particular one, you will extend your P1, P2, extend it to get this straight line. Then join that straight line to the point D, to this point, to this particular point. Then measure this distance. It's called the lateral displacement D. I think this one is very easy. The stress here won't be much. You just measure the distance, repeat it for 65, 55, 45, 35, 25 degrees, and then you're plotting graph of D against the incident ray. Graph of this lateral displacement against the incident ray. This one came out in 1995. You measure the thickness of this, you measure the thickness of the glass block, then draw your normal, put the incident ray, and then your eye, angle of incidence, put pin P1 and P2, then the normal thing which is expected for all of them, you view from this point to this point to get P3 and P4, which will be in a straight line with P1 and P2. This is your angle of refraction, and then you will join this point to this imaginary. You have NX, join NX. For this particular experiment, you are interested in NX, and at the end, you label it as L. Find L raised to power minus 2, and then sine I, you get the sine I. You get sine I and square it, so that you will plot graph of L raised to power minus 2 against sine square I. This one came out in 1995. Then this particular one now that was repeated 2 times, it came out in 1999 and it was also repeated. Is in such a way that you draw your normal at O. Remember, here should be 1/4 of the distance from here to here. So you draw normal at O. Put your angle of incidence, your pin 1 and pin 2. Then get the emergent ray, which is pin 3 and pin 4, which will be in a straight line. When you view it, we are going to do the experiment. I just want to show you different ways to let you know that optics can come out in different ways. You cannot just conclude on one. All you have to do is, if you want to do optics, keep practicing with your students. That's why I'm listing all these questions for you, so that you keep practicing to make them to be very fast on the day of the exam, so that they can be able to get desired results. Please give this video a thumbs up, like this video. If you have not subscribed to this channel, please hit the subscribe button. Just tap the subscribe button, it's for free. Thank you so much. So now when you do that, you get, this is the point where the emergent ray came out. You label OT. Then with the center at O and any convenient radius, draw a circle to cut the angle of the incident ray and the refracted ray. Once you do the normal thing, which we do for all of them, which is putting pin 1 and pin 2 and getting pin 3 and 4, then join your emergent ray and the refracted ray with center at O and any radius of your choice. Just draw a circle to cut the incident ray and the refracted ray. When you do that, you now draw a perpendicular line at Rn. That's the point where it cuts the incident ray. You draw this line. The point where it cuts the refracted ray, you join it to this normal, so that you can get a perpendicular. That's a straight line here and a straight line here. So you measure Rn, which is that place it calls the incident ray. You measure this distance, measure mx from here to here, so that you will plot a graph of Rn against mx. I think I like this one too. You can practice it with your students. That one is from 1999 and it was repeated. Then another one I want us to look at is this one. This one that came out in 2002. Then finally, we'll look at this one. This is the one I want us to practice with. This last one is the one we are going to practice with. I'm going to write the procedures, then we'll get our readings and plot our graph. Okay, now we are required to provide the rectangular prism. Please, while using this, if you're tracing and it's like this, maintain the position. Okay, the refractive index of this is 1.5. So we were asked to provide it. Then pins, but we need just 4 pins. We need only 4 optical pins. The one that is straight, please, the one that is straight. We don't need anyone that is bent, or we need the one that is straight. 4 optical pins. Then we need drawing board. We need drawing board, plain sheet of paper. You may need like 5 plain sheets of paper, but because I'm just demonstrating and for me to capture because I'm capturing, I'm doing a video and I'm teaching as well, I will just use this one so that everything will show on one. But you are expected to bring sheets, not just one, like 5 for each person. Then other necessary material, which is the mass set. Please, you will need a good mass set. And the most important thing that you need in this mass set is the protractor. you will need it. So these are the things that we are going to use. Your complete math set with a very sharp pencil so that you will trace neatly. Then this protractor is very, very important because we'll be dealing with angles. Okay, and I want you to note that in all these things, good knowledge of the theory is very, very important. Remember, I said it during when I was introducing the video. If you refractive index is equal to sine I over sine R. Please, it's very important you know this. Sine I, this I is the incident angle. That is the angle which the incident ray makes with the normal. R is the angle of refraction, which is the angle the refracted ray makes with the normal. For this glass block, the refractive index is 1.5. So have the theory in mind so that even if you don't have any option, you must do optics and your values are somehow, with good knowledge of this theory, you can always get back and present something that is reasonable. So we can accept 1.3 to 1.5 for the refractive index of glass, giving it plus or minus 0.2. So let's look at the procedure. This procedure is from WAEC past questions 2011. Trace the outline ABC. Select a point N on AB such that AN is about 1/4 of AB. Remember, I said it. 1/4 of AB. Draw the normal LNN. Also draw a line RN to make an angle of theta equals 75 degrees with AB at N. Fix two pins at P1 and P2 on line RN. Replace the prism on its outline. Fix two other pins at P3 and P4 such that they appear to be in a straight line with the images of the pins at P1 and P2 when viewed through the prism from side DC. Remove the prism and the pins at P3 and P4. Draw a line to join P3 and P4. Produce line P3, P4 to meet the DC at O. Draw a line to join NO. Measure and record the values of MO and NO. Evaluate phi equals to MO, NO, and cos theta. We'll repeat it for 65, 55, 45, and 35. Remember what I told you at the beginning. Follow the instruction. It can come out in another way. Just draw this line, do this, measure this. Follow the instruction. Don't go in with anyone in mind. I will trace the 5 at once for 75, 65, 55, 45, and 35. I will trace it at once on the same paper to save our time since we are doing the video. Please make sure your work is very neat. Make sure your work, and remember what I said, don't turn this rectangular prism. Once you do one, don't turn it. Please, you can use 5 different papers, but please, since it's a video tutorial, let me do it once so that I can be very fast, so that the video will not be too long. Please practice with your students, giving them one paper each. They should write their name on it. So, this for the 5th one. That's why it takes time. By the time you do for each paper, but it's good you watch the video and prepare your mind before the exam. After tracing, let me complete the sides. Let me make sure that the parts that are not complete, that they are all fully joined to each of them. Neatness of work attracts mark, so make sure it's very neat. Make sure your work is very neat. For the teachers watching this video, practice with your learners. For the learners watching this video, don't relax until the exam is over. Practice so that your speed and accuracy will increase. It is not yet over until it's over. So I'm completing the small parts that didn't complete during the tracing. Okay, now the next procedure is draw the normal L. Okay, select a point N on AB such that AN is 1/4. Please, from here to here, let me check. From here to here is 10. Now I need 1/4 of it. 10, let me say 10/4. That's, let's say, like 2.5. So I can just say 2.5. I will mark out 2.5 and draw the normal L and M. Okay, remember it must cut. And one thing about light, you must make sure you label everything. A, B, C, D. A, B, C, D. A, B, C, D. You must label accordingly, according to the question. These are the things that will give you your mark. Now we have measured that our normal. Our normal is L and M. So now we'll do L and M. Let me repeat the same for the 5 of them. Remember, 1/4 for each of them. I've done that. I've put L and N. Please tell your students they should do it one. It's because I don't want to waste time, and this is a video tutorial. The next thing is for us to draw a line RN, that's the incident ray, to make an angle theta, which is equal to 75 degrees with AB at N. So we are going to draw an angle. Okay, that angle is the incident, that ray is the incident ray, but the angle has to be RN to make an angle theta, which is equal to 75 degrees with AB. Remember, it's not with the normal, it's with AB. You know, the one we are used to is making incident ray, that's to the normal. But this particular question said we should make that 75 degrees to be an angle theta 75 degrees with AB. Angle with AB. That's why I said the questions can change. Just practice with your students the question. You cannot say is this. It can change. Thousands of questions can come out when it comes to optics. So let me draw the line now. Then I have to measure 75 degrees with my protractor. Please make sure that this point, this center, and the line, everything must be in line. Then we'll measure out 75 degrees, which is at this point. This is 75. Okay, with N. Okay, this is N. You see that this line is in line with that line with the normal. Then this point is in line with line AB, so that I can measure from here 75 degrees. That's the theta. Okay, see how I got theta to be 75 degrees according to the question? I will replace this. That's why I said always keep it the way. Put two pins. Please, you can make sure that the two pins are far from each other. Like 4 cm is good, is recommended, but it's not compulsory. Just make sure they are far from each other. Okay, and make sure that the optical pins are straight on that line. Okay, you see how I've placed the pins. How I've placed the pins. Then I'm going to view. I'm going to view from this side. I'm going to view to get the image entry. Please, you view from this side. I don't know how you're going to see it in this video, but just view where all of them will be in a straight line. Where all of them, I have to bend and view it to get the point I'm looking for. So that is it. Where all of them will be in a straight line. Where all of them will be in a straight line. Not viewed from top, but viewed when viewed through the glass. When viewed through the glass. Not when viewed on top. No, when viewed through the glass. If you close one eyes and view it, you will actually get it. My students enjoy this practical a lot. They will close one eyes, bend down and be viewing to see. Some will see, some will not see. So if you practice well, you'll get used to it and be able to see. In order not to make this video too long, I'm going to repeat it for 65, 55, 45, and 55. And then use the values and plot our graph. Okay, once you join the emergent tray, you join it and label it P3, P4. You draw it so that it will meet the glass DC. It will meet the glass DC at O. So this is the emergent tray. So now I will join these points to the end so that I can get the point NO. Okay, I joined NO and MO. Remember, the 2 points that we are interested in is this NO and MO. You measure NO and MO so that we can evaluate phi to be equal to MO over NO and cos theta. So let me write out the table of values so that we can do the graph. Repeat it for 65, 55, 45, and 35. You know, the one we are doing is WAEC 2011 past question. And from the past question, the values obtained. These ones are in 3 decimal places because they are calculated values, but these ones 2 decimal place, 2 decimal place. Now we are plotting cos theta against phi. So I'm going to show you how to plot these close values. I'm going to use their values to plot and show you how to plot values like this and get the slope. And I did a video on how to plot graph, the secrets of passing WAEC making A. Please check the video. And also 60 must know formulas before your exam. Please watch these videos. We are going live on Saturday. You can join us around 1, 2. You can check the channel to join us on live classes where we'll be revising things we are expecting for theory and Excel. Please join that live class. Remember to subscribe to this channel and turn the bell notification so that you will get notified whenever our videos are up. So let's go right into plotting these values. When students see values like this in physics, they are always worried, physics graph, physics graph. That's why I picked these values from the past question to show you. This one, we are plotting cos theta against phi. You know they are close, 0.3, 0.4, 0.5, 0.7. They are so close. This one to 0.5, 0.4, 0.3. Please don't look at these values and be afraid. It's very, very easy to plot. Let me show you how to plot it. The first thing to do is to write what you are plotting. Let's label the graph. We'll say graph of cos theta against phi. Please put the label graph of cos theta against phi. Then the scale. Please always choose the scale. For the scale, I'm going to say cos theta axis. I'm bringing it down so that you can see it. And then phi axis. Please don't use S and Y. You can watch that video I did on WAEC mass scheme and how to plot graph. Okay, so that you have good understanding of the exam you're going to write. Okay, for this axis, which is cos theta, let me pick this one. The first thing to do is put this axis. This is cos theta. If there is a unit, you put the unit so that you won't lose mark for the axis. Now let me draw for this one as well. Draw it, and that's for phi. So the next thing to do is check for the highest value, that's 0.8. You have to make sure that you are going to start from 0 to that highest value without looking for your point. If you don't check all these things, you start writing, at the end you won't have your 0.8. So the closest to 0.8, let's say we can say 0.10. So we can now say here is 0. We can just use 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. Our 0.8 is here, 0.9, then the last one 0.10. Please make sure that the values you need, the highest one especially, so that you will not keep cleaning. Now let's look at phi. The highest value is 0.5, so we can still use 0.1. You can see that for each axis, 0.1 2 cm, from here to here is 2 cm, from here to here is 2 cm. We can say 2 cm is equal to 0.1 unit. Even for the other axis, 2 cm is equal to 0.1 unit. So here we can also use 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. Okay, so don't worry, since the values are 3, 4, it will still be somewhere here. Now 0 to 0.1, 0.1 to 0.2, you can see that from here to here is 0.1. When you add another 0.1, you get this. Add another 0.1, you get this, which means that the interval is 0.1, and we have 10 boxes inside. So 0.1 divided by 10 will give you that this tiny line, each of these is 0.01. The next tiny line inside is 0.0, just like that, so that we can have here 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, 0.09, and then 0.1. Now, for these values that have 34, I'm going to plot 0.34. This two is not up to 5. I won't approximate. So that when you use your calculator and get values like this, how will you plot it? For this one that is 0.574, I'll plot 0.75. For this one that is 0.707, I'll plot 0.71. I will approximate this 7 to 1. This one I'll plot 0.82. Okay, so let's start. When cos theta is 0.34, you check here is 0.3. remember, the next one 0.31, 0.32, 0.33, 0.34. I'll keep this ruler here. That's 0.34. That's for cos theta. Then phi is 0.23. I'll come here. This is 0.2, 0.21, 0.22, 0.23. You will now trace it up to the point where they meet. You mark it. Remember, when it's 0.34, which is 31, 32, 33, 34, we have the other one to be 0.23. Okay, so we can mark it here. Then for the next one, when cos theta is 0.42, this is 0.4. The first tiny line is 41. The next tiny line is 42. We'll get 0.28. I'm approximating this one to 28. Okay, so I will look for 0.2. 0.21, 0.22, 0.23, 0.24, 25, 26, 27, 28 is this one. You trace it. 0.282, 0.4, 0.41, 0.42. So this is for 0.42. I will mark the point of their intersection. Now, when it's 0.57, I will check cos phi. When is, this one is already 0.5. So you look for 5, 5, 6, 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7. When is 0.57, phi is 0.37. This is 0.3. Remember, this is 31, 32, 33, 34, 35, 36, 37, 37. Once you get it, you trace it to that point where they intersect. You use asterisk and mark it. Now, when cos theta is 0.71, I'll look for 0.71 here, and then look for 0.45. This is 0.4. Remember, this is 4.1, 4.2, 4.3, 4.4, 4.5. And mark it. Then when it's 0.82, this is 0.8, 81, 82. I will have 0.52. This is 5, 5, 1, 5, 2. So you see that plotting graph is very, very easy. No matter the values, it's just for you to look for the range. The number of buses inside is 10. Divide it and then give it that value 0.01 until you meet the other one. So let's now look for the line of best fit. Okay. So I'm using this to mark my line of best fit. For the slope, please always use a very big triangle. The bigger the triangle, the more accurate your result. So I'm taking this big triangle. Don't make your triangle small at all, so that you will get a better and more accurate result. So if this is a triangle I'm using now, let's get the change, let's get the change from here to here is the change in cos theta axis over the change in phi axis. That's from here to here. So when I want to get for cos theta, place it here, place it here. You read off the value. You read off the value. Remember, here is 0.919293. I can say 0.93 minus, remember this side, the vertical axis side, that's a cos theta. You now come and read off this one again, which is 0.2. Please don't make the mistake. Just calm down and look at it. It's not hard. Then once you have taken this side and this side, you come back and trace it to this place. This one is 0.6. 0.6 minus, look at the triangle we are using. So we have to trace this value. This is 0.11111213. So we can say 0.13. So let's get the slope. 0.93 minus 0.2. That will give us 0.73. 0.73 over the other one, 0.6 minus 0.13 will get 0.47. 0.47. So that the slope finally will be 0.73 divided by 0.47. That will give us approximately, let's say 1.55. That's what I have here. Okay. Let's look at the precautions. Please like this video, subscribe to this channel, share this video to someone. Just share it to someone. You'll be helping someone to get idea on what to do. Okay, you may not know the person you're helping until you share this video on your social media. So let's have, I ensured that the pins were vertically arrayed. That's the precaution. Number 2, I ensured that I avoided error due to parallax when reading the protractor and the meter rule. Then I ensured that the pins were reasonably spaced. And finally, I ensured neat traces. I know you enjoyed this video. Thank you for watching this video to this point. And I wish everyone writing exam this year all A's in Jesus' name. And for the teachers, your students will do well. Thank you for watching this video, liking this video, and subscribing to this channel. Thank you so much.